Our lecture today is about network models. We'll talk about layers and layered network models. So actually we use the concept of layer in many aspects of our daily life. For example, if two friends, for example, want to communicate through postal mail, using mail service, not email, using postal mail, okay? So you post the process of sending a letter to a friend would be complex if there were no services available from the post office. So if you look at the structure of this task, of sending a letter, so you are as a sender, you write the letter, put it in the envelope and drop it in the mailbox. That's your job. You'll not go further, okay? So your layer, the sender's layer or the highest layer, is your layer closest to you. You write your letter, put it in the envelope, attach a stamp and put it in the mailbox. So that is your job. You are done. Now the next layer, the letter is carried from the mailbox to post office. So the postman will come to the letter box, mailbox, and collect all the letters and take them to the post office. That's the postman's job, or some person from the postal service. That's a middle layer. Then at the post office, the letter is delivered to a carrier by the post office. So at the post office, they will sort these letters and give them to appropriate carriers so that they send them to the correct destination or another post office. So that's the lowest layer. Now at the other side, the letter is delivered from the carrier to the post office. So this is one post office. There is another post office on the other side. Let's say this is one city, this post office. The other post office is in another city. So the letter from this post office in, say, The Hague, for example, is delivered to the post office at another city, say Erbil. Now, the letter is delivered from the carrier to the post office. So the carrier, like say truck or whatever, it will deliver it to the post office. The letter is carried from post office to the mailbox.
دكتور
So
بس تسجيل المحاضرة.
بلا تسجيل كري. So the letter from the post office will be delivered to your mailbox. For example, you have your mailbox in front of your house. The postman will carry the letter and put it in your mailbox. You'll open your mailbox, pick the letter and remove the envelope and read the message. So this is almost opposite to the sender side. So in the sender, you write, you put in the envelope, and then you drop it in the mailbox. Here you pick it from the mailbox, remove the envelope, and read the message. Okay, so these are the closest layers to the user, and these are the furthest or lowest layer. Okay, so we actually use layering in many aspects of our daily life. Now TCP/IP, the Internet Protocol and the Transmission Control Protocol, also uses layered structure. Transmission Control Protocol, which is TCP, Internet Protocol IP, is a protocol suite used in the internet today. It's the most actually widely used and internet protocol. It is a hierarchical protocol made up of interactive modules, each of which provides a specific functionality. We'll study these functionalities in more detail. Hierarchical means what? That each upper level protocol is supported by the services provided by one or more lower level protocols. So it's a layered structure. So this is the TCP/IP protocol suite. We have application layer, closest layer to the user. Now when I speak, I talk, my voice is, for example, collected by some application. That's application layer. Okay, I'm working in the application layer. Then below is the transport layer. Then below that is the internet layer. This is the TCP/IP protocol suite. Okay, we have another model, layered model, which we'll see at the end of this lecture. Below the internet is the network layer, and the lowest is the lowest is the hardware devices, which is called the physical layer. So names of these layers: application, transport. The internet layer is network. The network interface layer, which deals with network interface, let's say, is data link, and the lowest layer is a physical layer. So we'll name them: layer 1 physical, 2 data link, 3 network, 4 transport, 5 application. This is in TCP/IP protocol suite. So when we say layer 1, we mean the physical layer. When we say layer 5, means application layer. So application layer is where you have applications interacting with the user, and it's the closest layer to the user. Okay, so you have, for example, video conferencing application, chatting application, whatever. These applications are running in this layer. Of course, when they need to communicate, they need the services provided by the lower layers so that they can send and receive data. We see that in more detail when we study these layers. Actually, we'll study these layers layer by layer. We'll study the physical layer first, then we go to data link layer, then network layer, and transport, and application. We'll follow the TCP/IP protocol suite in our course. So we study by this layer and end by this application layer. And in each layer, we study the protocols and services provided by these layers. So if you have, for example, node A wants to communicate with node B, when you send information, your information or your data should go through all these layers. So you go down through these layers. Then you have intermediate devices like switches, routers in the network. So each device will deal with the data according to its layered structure. For example, a switch can just 1 second so that so a switch in a computer, now you have the whole layer. So you start from application and go to the physical. So your application, as we said, can be, for example, a video conferencing application. So what's the physical layer here in your computer, on your computer? What's the physical layer? You can tell me. What can represent the physical layer? What's actually, let's say, what's the physical layer? Okay, okay, we'll go to details later. So in a switch can only go to layer 2, which is the data link layer. So from physical to data link, you can process the data up to data link layer. Then when the data is sent back, you go down to the physical layer and then send it. But a router is called a layer 3 device because it can deal with data up to network layer. So you go from layer 1, 2, 3. Here is layer 2 device. We call a switch a layer 2 device because it can process data up to layer 2, but a router up to layer 3. A host all up to the top layer, which is layer 5 or application layer. So when the router sends the data, again it will do the opposite and go from network, data link, physical layer, and then until you arrive at the destination. So at the destination, the opposite will happen. So the data will go from physical to data link to network to transport to application. Okay. So what happens when we send data between these layers? So logical connections between TCP/IP layers. Using logical connections makes it easier for us to think about the duty of each layer. The duty of the application, transport, and network layers is end-to-end delivery. The domain of duty of the top 3 layers is the internet. Okay, so application, transport, and network, their duty is end-to-end delivery. The duty of the data link and physical layer is hop to hop. We'll study these in more detail when we I'll explain a bit more today in this lecture about these. So let's study each layer in a bit of more detail, but actually we'll go into the details of each layer in the coming lecture. So this lecture is an introduction to the layered model because we'll follow this model. Therefore you have to have an overview of this model, and then we'll go to the details of these layers one by one. So the lowest layer, which is the layer closest to the furthest from the user, or the layer that is furthest from the user, as we said, and it's called the physical layer. So physical layer actually deals with bits of data. So we have data, raw data, bits, 0 ones actually. So we deal with bits of data, and we deal with physical things like transmission medium. This transmission medium can be, for example, a coaxial cable, an Ethernet cable, a fiber cable, or a wireless media, whatever it is. So in physical layer, we'll deal with individual bits. So the movement of individual bits from one side to the other side. So these bits, we treat them here in the physical layer. We send them over transmission medium, which can be, as we said, like a cable, coaxial, or a wireless channel, or a fiber cable, or Ethernet cable or light, whatever it is. Okay, so this is the physical layer. So we deliver the data from one node here to another node. Think of it like you have two, so you have this stream, you send it over wireless link to the other side and you receive the data, or you have a cable or whatever. So this layer is layer 1, it's called the physical layer. Then comes on top of physical, layer 2 is the data link layer. So data link layer is responsible for moving, you see here the difference, moving frames from one hop to the next hop. So the physical was responsible for individual bits, but here we don't talk about bits, we talk about frames. A frame is a collection of bits. So how this frame is constructed, how what is the content, we'll study that in more detail. But generally, we'll have the data from upper layer. Upper layer is what? Is layer 3, network layer. Okay. So the network layer data will be encapsulated in some headers and some trailers. So we have some headers mostly we add to the data. So I ask a simple question here. Why do you think this header data is important? You can answer this question. So why we don't send the data, raw data? Think about this example. Okay. Who can answer the question?
Maybe it contains the address of the destination.
Well done, Afi Ahmed. Okay, so who can connect that to this example? Okay, let me explain. If I have a letter, okay, and I want to send it to a friend in another city. So if I write the letter in a paper and put it in the mailbox, would you think it will be delivered to the destination, to the other side? There is nothing written on it, just the letter, the contents of the text I wanted to write. No addresses, nothing at all, just data. The data is a message that I wanted to send to my friend. Of course, when it's arrived at the post office will see there is no destination address, so they will just discard it because there is no sender, no receiver information. So they will even not be able to deliver it back to you to tell you that this message was not deliverable. You have to resend it because you didn't write anything on it. So when you write the message, you may need to write your own address and write the receiver's address. So this is exactly what we do here. When we do add these headers will contain information about source and destination addresses. But the addresses will be different actually. Data link layer addresses are different from network layer addresses, from transport layer addresses. We'll understand these addresses in more detail when we deal with these layers. So we need to add headers. These headers actually do more, not only just to ensure that message is delivered to the correct destination. They do even more functionality. For example, if some errors happened here, because this is a channel, for example, you send it over wireless channel. If some data changed, for example, this one changed to 0, and the other side, if some errors happen, depends on what application you are using. But for example, if it's a binary file, a single bit change maybe damage the whole file. So you have to be able to detect at least if there is any error, and it's better of course if you can correct the error. So we have data also here to detect and correct errors. Okay, we'll have actually these data in most of the layers, not only data link layer. We'll study that in more detail. So let's think about an example here, hop-to-hop delivery. Hop, we mean by hop, this hop, this a hop, this a hop. Okay, so these are hops. So when you send, I sends a message. So this is a hop-to-hop delivery process. Now look, this is hop, this is hop, this is a link actually. So when you the message moved from here to here, you moved from one hop to another hop. So you go from this hop to another hop. Actually is TCP.
دكتور
بله.
أودي دير نوكت الدفمن
Pointer.
بله pointer.
Oh, okay, sorry, let's see. Now is working.
No.
So by hop we mean this is a hop, this is a hop. So when we send this from here to here, the message, we are delivering from one hop to another hop. The internet is actually a packet switch, not circuit switch. We studied packet switching and circuit switching last lecture. So if I wants to send a message to F, in this case we only have one path, so all the packets would go this direction. But if there was another link, for example here, let's say to this router on something, so in this case you have many links. So one packet can go this way, another packet may go this way, don't go through. Of course it's not convenient to use this way, but you may think of a more complex, let's say there is another device connected to this router through a link, and then there is link here and link here. So if I wants to connect to say C, in this case I can send a packet and it can go through this path. Another packet may go through this path, another one may go through this, another one may go, so you don't know which path the packet will go, unless of course you know exactly what protocol you are using and the metrics and more details. But generally when we say packet switching, means that we don't have an established connection to the destination. There is no fixed connection. This is not fixed. This time it worked this way, the other time the packet may go that way. Okay, so when we deliver packets, actually we will use packets so they can go any route. There is no fixed route from the source to the destination. By hop we mean any of these, so these are hops. can be a switch, a router. Mostly routers and end devices are called hops. So when we have a switch, this is actually not correct, so it should be 3 layers. Okay. Now the next layer, I'll explain this and we'll go for a rest. The layer 3 is network layer. So below this is data link layer. Okay. Above this is what? Transport layer. So again we have this encapsulation or adding headers. When we add headers, we call this process encapsulation. Okay. So we encapsulate the data in some capsule of headers. Okay, we encapsulate it. So here we have the transport layer data. So the transport layer data is encapsulated. We add header. Now this as a whole will be what? Data link layer data. So this header with this data will be the data for data link layer. Okay, so here in the lower layer we'll add the header for the layer 2. So all this data is the data, I mean the header plus data is the data for the lower layer. Okay, so the layer 2 data include also this header 3 or layer 3 headers. So again this network, this layer is responsible for delivery of individual packets. Okay, so as we said before, a packet can travel from here to this through this road, but if there was another road, it may go through the other road. So this is the responsibility of the network layer to deliver the data from source host to the destination host. So think of this. We say source host to destination host. So this is a host and this is a host. So from here to here, the process is the delivery process is done by using the network layer services. So the network layer is responsible from delivering from here to here. Okay, I'll ask you a question and then we'll end this. Think about it, and at the beginning of the next hour we'll study, we'll discuss. So in this computer I'm talking now and I'm communicating with you through Zoom, for example. In this computer there are many applications running. Some application send the data. So on the other side, which application, there are also many applications running, which application will receive the data? So the process of the service of network layer is to deliver from here to here, but here there are many applications and here there are many applications. So how we deliver the data from this application to the correct application in the other side? Okay, think about this and see what is layer responsible for this process. We'll discuss that in the next hour. Okay, so we are done now with this hour and